I must be getting tired. I just did this whole problem and the recording wasn't working. So I'll try to go back over what I did. So I'm graphing this and graphing this. This one's easy. It's a parabola that's moved down 16. So I 10, 11, 12, 13, 14, 15, 16. And I did the parabola. Over 1 up 1, over 2 up 4, over 3 up 9, over 4 up 16. And on both sides. So I graph the parabola. This one's a line, but e to the x is really close to 0, so a line times almost 0 is going to be really close to this axis. And then the e function goes up like this, but this is negative, so it's going to be down here until it's going to pull up eventually. So I type this in y1. I type this one G in Y2 and got this graph. And I had my window as zoom 6 and I couldn't see the bottom down there. I got some ink on my screen. I couldn't see the bottom, so I went to my window and said I need to look lower than 10, so I went to minus 20, and now I can see that it goes through minus 16 here, and the other one comes down and go through minus 16. They both, that one hits at 4 and minus 4 and 4. This one doesn't go through 4, but it does go, both of them go through minus 16. So I said in the third quadrant, the area between it. So I want this, which is this. So I got to take the top one, which is this one, minus the bottom one, and then integrate from where they intersect. So I need to find that intersection point, the x and y. Desmos, you can tap on it, and the calculator goes second, calculate the intersection, and it says, is that one of the equations? I say yes by pressing enter, and it says, is that one of the equations, that red one? I say yes by pressing enter, and then I don't need this intersection, I need that one over there, so I'm going to move closer to it, and then press enter, and it says at 3.92 is the x. The y is minus 0.62. But if I slice it vertically, the width of the slice is dx, and so I want to take the top curve, because it's already in x's, minus the bottom curve, evaluate from there to 0, from 3.9 to 0, to get me that area. Now, the shortcut to typing that in on a calculator is to type in the integral from negative 3.92 to 0 of y1, and so I'll go through that again. So it's math number 9 from negative 3.92, where they intersected on the x, to 0 of y1, so I push vars function y1 minus vars function y variables function y2 dx in those, and that's how I type that in, and you get the 23.349. That's the area of this. The square root is a parabola on its side, but this one's been moved to the left 1, so you can type that into the calculator, but that's pretty easy to graph. And then if it's spun around the x-axis, this goes down to here, which would go through there and there. And since this is solid disk, no holes, it might be easiest to do vertical disks, which are just uh, cylinders, pi r squared h. The height of this cylinder, if you look at it this way, the height is a dx, a very thin slice of this shape. The radius, since this is a point on the curve, it's x to the y-axis and y to the x-axis. So the radius is y, pi r squared, pi y squared dx from 0 to 4, because it said to do from 0 to 4. So I got to do y squared. Well, y is this got the square root, so if I square it, it's just going to be x plus 1. So I got the pi y squared is this dx. This is easy to integrate. Put in the 4, and I get 16 divided by 2, 8 plus 4, and that's 12 times pi, the answer. Okay. Number 3, the one that caused people the most trouble. There's a lot of them that cause trouble, but this one caused the most trouble. So let's do this one carefully. I'm rotating around x equal minus 2. X equals a vertical line, and it's to the left of the origin, so I better put my origin over here so I've got room to do over that side. And I'll put my y, I don't know, here. Or my x here, y here. That's what I meant to say. All right, so this is going to be 2, and this is 4, and 2, and I've got to draw a parabola. So 0, 0, 1, 1, 2, 4. And I can draw it over in this quadrant, but I don't need it because it said, think of this parabola and y equal 4 and the y-axis, so that could be this or that in the first quadrant. So that's just this. Rotated about x equal minus 2. So I'm thinking about this shape flipping over this. So it's 2 to 4 over. 2 to 4. This is 2 away, so it's 2 away. That's where the y-axis gets taken, and that's where this shape goes. So I don't need anything to do with that. Now, put the dang point on the curve, which a lot of you just didn't want to do, and draw where x is. X goes from the point to the y-axis. That is x. Y goes from the point to the x-axis. Now, if we're going to take a slice perpendicular to the axis, then we're doing washers. This thing is going to come up, over, and land over here, and this point's going to come up, over, and land there. So, the thickness of this disk is up and down. So the thickness is dy. And it has a large radius. Here's the center. Here's the large radius, and it goes around. So the large radius is from here to there. But this is x. X is not the large radius, it's all of this. So when you're doing washer, it's pi large radius squared minus little radius squared d something. So the large radius is x plus 2 more. And it's got to be squared. The small radius is 2. It's always 2. All the way down, it's 2. And the thickness of the slice, pi r squared h, that's y direction. And y goes, to get all the disks that make this thing, will from 0 to 4. Now, if I type that into my calculator, I'll get what this one says should be. So I've got math 9 from 0 to 4 of, and I got a parenthesis x plus 2 close parenthesis squared minus 2 squared, 4 dx, no, dy, oh, dy, so I've got a problem here. Alpha y, where's y? Down somewhere on this, there's y. I got to get the x out of there. Well, x is equal to the square root of y, so I got to put there y in the square root on just the y. So second insert square root. Oh, that's got to be y inside it. It didn't want to do that, so alpha y, and get rid of that y. And all this is times pi. So it says that area is 92.15. Now I'm going to set up the shell, and I better be able to integrate it and get it 92.5 to make sure I'm doing the same thing, and then I'm going to work out one. I might even work out both. So now the shell. So now this is the axis. I got to slice parallel. So I'll use my XY point and draw a slice that's going to be, thickness is dx, and that little segment is going to come up and go down over here. So its radius, because it's the distance clear around, is 2 pi r. That's 2 pi r times the height times the thickness. Integrated. So it's 2 pi r. Well, it's the same radius as the disk is, the large one. It's x plus 2 more. Its height is this. That's not y. Y is from the point to the x-axis. This height is 4. So that length there is 4 minus y. And the thickness of this rectangle that goes around is dx. And so dx, to get all the rings that go around in here, x has got to go from 0 to 2. There, first one would go to there, and then further out goes further over. Even further out goes further over, all the way out. So I'm getting all this and all the stuff up here and behind by just going from 0 to 2 for the x. All right. Now, can I do this? That's x. Oh, that's a y. But y is x squared. So I can type that in. I'm going to go math 9. Oh, and I need a 2 pi in front of this, so let's just start over. 2 pi math number 9, 0 to 2 of my first quantity is x plus 2, parenthesis, x plus 2. My second quantity is 4 minus x squared, close parenthesis, dx. And that works out to be hopefully the same, if I didn't make any mistakes. It's taking a little longer to think this one through. And little thing here says it's still thinking. Thinking, I've been thinking. Uh-oh. 2. It says it has a tolerance error problem. Oh, I hit divide instead of subtract. There's the problem. Subtract. All right, now it shouldn't take us. Oh, that happened way faster. And it is the same, 92.15. All right. Okay, so now, which one's the easiest to work out? They're both pretty easy to work out. This needed to be the square root of there, so I got pi integral from 0 to 4 of square root of y plus 2 minus 4, and this is squared, dy. That squared is square root of y plus 2 times its self. So that's going to be y plus 2 squared y plus 2 squared y plus 4 square root of y plus 4 minus 4. So this is going to be pi. Antiderivative of y is y squared over 2. Antiderivative of y to the 1/2 is y to the 3/2 over 3/2. Evaluated from 0 to 4. And so I get pi. 4 squared is 16, divided by 2 is 8. Square root of 4 is 2. Cubed is 8 times 4 is 32 times 2, 64 thirds. Minus putting 0 in there, and I get 0. So 3 goes in there, 21 and 1/3 plus 8 times pi. So 29 and 1/3 pi. Hopefully is 92.15. 29 plus 1 divided by 3 times pi. And that's the number we had. This one is going to be 2 pi, 0 to 2. This is x squared, so I got x times 4. X times x squared. 2 times 4. 2 times x squared. So 2 pi 2x squared minus x to the 4th over 4 plus 8x minus 2x to the 3rd over 3. Evaluate it from 0 to 2. 0 is going to give me nothing. So I only have to put the 2 in. So I'm going to get 2 pi. 4 times 2 is 8. 16 divided by 4 is minus 4. Plus 16. 8 16/3 minus 16/3. 8 minus 4 is 4. 16 is 20. Minus 5 1/3. So that's 14 2/3 times 2, which is 28. 28 4/3, 29 1/3 times pi. Same answer. There's all the work. Okay. This one. For some reason, some of you have a hard time visualizing that we're going to be taking water out of this half a circle, rectangular top tank. And if we're lifting water out of it, we have to have the same level of water all the way through. So if I thought of it here, there's no circle here. The same level would go all the way back here and back across and come back down here. That would be water that's all at the same level if it had a little bit of height in it. That water all has to be lifted the same distance. And a level down here would be lifted another distance. And the level at the top would be lifted less distance. And it needs to go clear up to a tanker that's 8 meters higher than the top of the tank. So there's a tanker up here that we're taking all this water and pumping it all the way up into it. So it got 8 meters higher. All right. Now, you can put your coordinate system anywhere you want, but there's a circle here, half a circle, that's this end depends on. So you're probably going to need to be able to write the equation of the circle. And the easiest way to write the equation of a circle is to put the coordinates at the center of the circle. So that x squared plus y squared equals r squared. If I put x there and you guys like to put y up here, I would put it down here, but I'll put it up here for you. Then a point on this. This is the x-axis. That's the labeling of the axis, but this point, x, y. I'm really trying to make a point. Draw. X-coordinate is the distance from this point to the y-axis. That is x, the length x. Y is from the point to the x-axis. Please draw those so that you get this not confused. Okay. So we have to know how much this slice of water weighs, because it's that weight that we're lifting 8 meters above the top of the tank. So we're lifting it this much and the 8 meters. So the weight depends on its weight density. Pounds is a weight. Kilograms is a mass. That's not a weight. I told you that the weight density is 9.8 times this, so 9,800 newtons per meter cubed. So we got to take the density, and if this is in meters, we're going to use the 9,800 newtons per meter cubed. So now we got to take it times the volume of this slice to get rid of the meters cubed, so we get the weight in newtons. So this has a width of not x, but 2x, a length of, well, everywhere in there it's 4 meters long. So 2x meters one direction, 4 meters this direction, and a thickness that is, if you're putting y up and down, the thickness is dy. Meters, meters, and meters are going to cancel the meters, and we'll now have newtons amount of weight. And the weight is what we have to lift. This is the force times the distance. The distance this slice has to go up is the 8 to the truck and how far down it is. And this is y. But this y will be a negative number if you put positive up there. So we have to go, the distance it's being lifted is 8 minus the minus y, which makes it plus, because y is negative. So 8 plus y. And y, dy, is got to go. We're going to take all the slices from this little narrow one here to the really wider one here, from the bottom of the tank to here. So y is going to be, all the slices end up being between minus 0.5 meters, because the diameter is 1, so the radius is 0.5, up to y is 0. So this is ready to integrate if they were all y's. We got an x, so we got to get rid of that x. Circle, x squared plus y squared equals r squared if the center, the coordinate system is at the center of the circle. We got to get rid of the x. Solve for x. See, the radius is 0.5, so we got 0.5 squared minus y squared square root. That's what x is. So we have 9,800 integral from minus 0.5 to 0 of, oh, see, there's 2 times 4, that's 8, that could be taken out, so then it would be just an x times 8 minus y dy. And now it's time to pull out the calculator. Math 9. Oh. 8 times 9,800. Now, Math 9. negative 0.50. I got this square root of 0.5 squared minus y squared. Then I've got a parenthesis 8 minus y. Oh, I need to close that parenthesis. And with y. And it's thinking, and it comes up with 126,417 joules. If you do this in the metric system, it's joules. Wasn't on the test. I wasn't terribly nasty about getting the units right, but that would be in joules. 5. The pressure depends only on the depth. In this tank, that's 18 by 8 by 6 feet back, height of 8 feet, 6 feet back, filled to within 1 foot of the top. So this is in feet. So the water depth is 7 feet. And so we're not worried about this one. We want to do the English. This is 62.4 pounds per cubic foot. And to find the pressure at the bottom, you just got to know how deep it is. It's 7 feet. That cancels one of the feet, and we get pounds per square foot, which is pressure, force on a square area. So part A, worth the 2 points of this, was just 62.4 times 7, 436 pounds of pressure, 437 pounds of pressure on every foot squared of at this depth. Okay. Now determine how hard the water is pushing on the larger side, which is this front side. Well, it doesn't push very hard at the top. The more pressure is at the bottom. So it changes. So we use calculus and we say the pressure at some distance down. So now we need to have a coordinate system. And a lot of you put it at the bottom. Some of you put it in the center or at one corner or at the other corner. It really doesn't matter on this because it stays the same across. So if you put X here and Y here, like a lot of you did, and then you do a slice down here where the water is pushing on this wall, this area, this rectangle, not a slice all the way through, because we don't care about there. We just want to know how hard is it pushing on this wall, on that rectangle. So the height of this is going to be a dy. The length of it is always 18. The pressure at that depth is measured from the water down, top of the water down, not from the top of the box. That has nothing to do with the pressure. Don't go from the bottom because the pressure is more down here and it gets less as you go up. So you need to know how far down times the density. So if this is the slice and this is the coordinate system, this direction is in y, and from the x-axis to the slice, that's y. But we need the depth. So it's 7 minus y is the depth. So we got 7 minus y times the density. That's the pressure at this depth pushing on this area. Remember, the pressure is so many pounds per square foot. So we've got the pressure, we have to multiply it by an area. Well, it's 18 by dy. Feet, canceling the other two, because this cancels one other foot. And so we now just have to add it up. And if you put the coordinate system here, you're adding from y being 0, right at the bottom, how much pressure on that first slice, all the way to the top. And that one you can just type in. No pi, no circles, no nothings fancy. 0, 7, 62.4, parenthesis, 7 minus y. If you want to do y, you could just do it all with x's. And 18 dy. And it's pushing with 27,518 pounds of force. This is pounds per foot cubed. That's foot, that's foots, and that's foots, canceling all the foot cubes. So we just get pounds of force. Finally, the last page. 6. Square root cubed that's not a problem, but putting 0 in a fraction is a problem. There's the problem. So we've got to go limit as something, b, c, k, whatever, b approaches 0 of the antiderivative from b to 6 of 3x to the negative 3 halves. Changing the sign brings this up. No flipping of the power. dx. So, limit as b goes to 0. 3 antiderivative of this, we add 1 to this, and we get x to the minus 1 half divided by minus 1 half, evaluated from b to 6. So that's the limit as b goes to 0. So x to the minus 1 half means it belongs in the denominator. Half is a square root, so we got, and this we can get out of there by multiplying by negative 2 over 1, negative 2 over 1, and so we get negative 6 over the square root of x, evaluated from b to 6, which is the limit as b approaches 0 of putting 6 in here. We get negative 6 over the square root of 6 minus a negative 6 over the square root of b, and I need to see all the way to there, and then do your limit. And if you're not sure what happens, this is the b. 6's and b look a lot alike. I need to know what this is just a number. I need to know what happens to this as b gets close to 0. If you're not sure, graph it. So it's minus minus, so we don't, the minus minus cancel. So it's, what we're interested in is 6 divided by the square root of x when x gets closer to 0. So we're going to look at this graph. And when we go towards 0, this graph explodes, goes off to infinity. So this diverges. Determine the mass on a rod that's 4-meter long rod. So this is the density, minus 1/3 cosine x plus 1. That's in kilograms per meter. So we got to take times a chunk, and that'll give you the kilograms. And I want mass, so we don't have to change this to newtons. And we want to add up all the little chunks, the little chunk of it with that mass at a different x distances for x is measured there, and it's 4 meters long, so from 0 to 4, and we get math 9, 0, 4, negative 1 divided by 3 cosine x. Ooh, cosine. I better make sure my mode is in radians. Oh, it's not. Enter. Plus 1 dx. And I get a total mass of 4.25 kilograms. Now the center mass is this integral in the denominator, and in the numerator the same integral times x. So we get a torque. So I can do the same integral, just need to add an x times the inside. So I'll bring that one back and just move in here, and I need to put another parenthesis up at the beginning and one right there times x. So all that inside is times x. That divided by my last answer. And I get 2.24 meters from the left end. because this was the X, and it started an X at the left end. Okay.